have that record. Today we're going to be talking about creating molds. This is going to be the first of a two-part series. The first part, we're just going to talk about some of the tools you can use to make molds in SOLIDWORKS. And then the second part, we're going to talk a little bit more about the actual design of the molds, how to add different features to them in terms of, runners and vents and all those kind of little features to make the molds a little bit more feasible in terms of, being able to actually make stuff. So first part, making the mold cavity. Second part, making the geometry to make the mold usable, right? We're going to start off with looking at a part that I've pre-made. So if you go on to Canvas, obviously you're going to need SOLIDWORKS. Come into week, I'm on the wrong page. Should be week 10, but you want lesson 10, not the progress submission page. And download this Eagle 2022 SLD PRT. This is a part that's been kind of pre-optimized for making a mold. And I don't know if I'm actually going to make this into something, but maybe I'll try and make this into a mold next week so we can make like little chocolate eagles or something for senior dinner. I don't know if it's like a good size to do that or not, but I made this little guy yesterday, right? And you can see he's got a little eagle and it's got WCE, so Whitaker College of Engineering 2022. And it's a nice little kind of design thing here, right? So this part has already been optimized for making into a mold. It has a draft on all of the surfaces normal to the face. And you can see that it's using a combination of draft angles in the boss extrude. Wait, let that load so you guys can see it. Actually, sorry, they usually just drafts on the parts. So there's a draft here, there's a draft here. That's actually for the eye, right? And so this, I think the lettering has a draft on the boss extrude. So you can either use the draft tool to add a draft to a surface, or when you extrude it, you can draft it like that. You have to be a little bit careful. The reason that I have it done like this is that I have these faces that kind of extend across multiple extrusions. And there are a few areas like right here, right, where the draft is behaving a little bit strangely, right? I'm not sure why it's doing that actually. And so I'm actually going to investigate one of these drafts to see if I can't fix that. So this is the part itself. When using the draft, what we're just saying here is, where do I want the draft angle to start? That's the neutral plane. And then I have all the faces that I've selected, which is the faces going around the entire perimeter of this part, including the head, and the angle. So again, I can accept that. And I get this piece here, which looks okay. And then I just mirrored it about its backside. Look at the opposite side. I'm going to try changing that to maybe a geometry pattern, because I want it to, you can see that's what I want it to look like on the other side. Yeah. So I just moved that from being a feature pattern to geometry pattern because the draft was kind of messing up this center face there. That looks better. So any questions on the part itself? Pretty straightforward. So if I have a part and it's already set up with the appropriate draft angles to be able to make it into our mold, we can start just by looking at doing some analysis to make sure that the thing is set up correctly. So I'm going to start off with the draft analysis tool. You can get this by going to search, we'll talk about that using draft analysis. You can also turn on the mold toolbar, going to tabs, and go to mold tools. Then you gotta wait for that to load. You can also just go into insert molds. Oh, it's not there. Where is it? It may be under surface or face. The draft analysis? Oh, sorry. Yeah, so I was looking, I thought it was in molds, which is why again, I was using search because I don't have to remember where things are. It's here in the mold tools. I'm not sure. Maybe it's in view? I'm not sure where the draft analysis is inside there. But anyways, you can get the mold tools, you can search for it. Basically, you turn this on, you specify which direction you're going to have the mold come apart in. So I'm going to just pick on my, I think it's my top plane, right? And then you can see here that all the ones that have a positive draft are green. All the ones that have a negative draft are red. And anything that doesn't have a draft angle is going to be yellow. And what I want to do when I'm looking at this is if I look at this from one side, I want to see all green. Because that means that all of these faces have a positive draft compared to that direction. Does that make sense? So if I pull this thing apart, all those faces are going to pull out easily. Then if I go to the opposite side of this, I'm going to do normal 2 again. It should all be red. So if it's all green on one side and all red on the other side, then you have a part that is feasible to produce. If I had some kind of overhang here where one of these drafts is going in the wrong direction, it would show up as being green on the red side or red on the green side. You also want to look kind of from more than one angle. Oh, I don't want to actually select that face. I'm just clicking on the check mark to get rid of that. It'll stay on. The coloring will stay on until you turn the tool off. But you can see here that all this looks okay. I do have that one yellow surface right here. Maybe you guys can see that or not. Right in the middle. And so that one does not have a draft angle. It's actually flat. For this kind of one, that's a small surface. I probably don't need to worry too much about that causing the issue in my mold, right? I do have one problem with that though, is that I don't have a split going along that. I do want my mold to divide at that location. And I've done parting lines everywhere else, but you want to make sure that you have a path of edges around your entire part to use for your parting lines. So what I'm gonna do is I'm actually gonna split this face to make this into 2 faces. Did you have a question, Patrick?
Yeah, I think under the second late, so I was wondering what you chose for your analysis parameters on your draft analysis.
For the draft analysis? Yeah, so in the draft analysis, the only thing that I'm doing here, I'm just gonna turn it off and then back on. I use the top plane, and it's just the direction of the pull that you're looking at here. It actually seems like it's slowing down my computer, so I'm going to leave it off just because it's having to calculate the normal vectors for that. That specifies what angle do you want to consider to be a sufficiently large draft. So in this case, if I make this, say if I make it 15 degrees, right? And then I go to my top plane. Now all those ones, since their draft angle is only like 5 degrees, I think, maybe it's 10. That shows up as yellow because it's not a large enough draft angle, right? So in the draft analysis, you can specify kind of what you consider to be a large enough draft based off of the type of material you're working with and the type of molds you're designing, right? 3 is going to be fine for pretty much everything. You can have much shallower drafts depending on how precise your molds are being designed. 2 is kind of the standard, right? So if you have a 2-degree draft, you're going to be fine. If you are making a precise part and you want to use a shallower draft than that, like you want to use a 1 degree or something like that, you're fine in a lot of materials, but it's probably going to decrease the cycle time that you can do for the mold, right? So the number of parts you can make per minute or per second is going to be lower because it's going to take more force to eject that from the mold than it would if it was a higher draft angle, right? It's also going to be a little bit harder to get those kind of smooth edges. This is not the best mold design because I have hard edges around this entire part. If I really wanted to optimize this for even better performance, I'd take all those top edges and round them all, right? Which I could do just by using this very small round on the entire surface. I don't want to break the part right now because I do have a fairly complex geometry here. So I'm not going to try and do that live. But as you're working on your own parts, you can do that just to investigate it. Is that okay though? Everybody's good with that? Again, I'm going to cancel this. You can leave the draft analysis on all the time, and it'll just constantly run as you modify the part. But if your computer is slowing down, I would suggest just turning it off. It's a toggle on, toggle off kind of thing, right? So if I turn it on, it stays on until I turn it back off by pushing the button again. Does that make sense to everybody? So it'll keep running itself until you stop it. So just as an example here, I have this face and I want to split that face so that way it has a single line. If you guys are following along and you didn't change your mirror to be a geometry pattern, instead of a feature pattern, make sure you change that. Otherwise, this face is not gonna look the same as what I have here. And I'm gonna split that face just using the split tool. So a split line. And I'm just gonna do the intersection. I don't wanna use the feature. I'm gonna use the intersection between my top plane and my line right here. I'm gonna accept that. The reason I'm doing that is because I actually wanna have an edge on my part where I'm going to split the mold, right? And we'll cover another example where this is non-planar, but in this example, I wanna have an edge that is aligned with my top plane for the entire perimeter of the part. So hopefully that makes sense. You want me to do that one more time? Yeah. So again, I'm going to go into the split line tool. I'm just going to search for it. If you want to find it, I think you go to curves. It's there. And then I'm going to use the intersection between the top plane and this face. I don't know if I can flip those. No, you don't. You can't flip them. The face has to be the second selection. So I'd use the top plane for the first selection and then the face for the second selection, and it should work fine. That's also a very useful tool to use if you're trying to apply like offsets. Like say you want to pull a certain, like a part of a face out to make it thicker, you can do the split line and then you can extrude that face or pull that face out. Or if you want to apply loads to a specific area of a part, we did that in the FEA analysis on the bridge. We used the split lines to make different faces so we could apply loads to just the middle of the bridge, right? A good tool to kind of remember that's there. Everyone's good? All right, let's move on to the next part. Next thing I need to do is do a parting tool. I'm gonna go into the tools listing here just because it's got kind of a nice layout in terms of how you wanna do these different things. So we're gonna do parting line, parting surface, tooling split. The shut-off surfaces is something you would do if you have areas of a part that you don't want to be included in the mold. So if I had a hole that I didn't want to include in my initial mold design, because again, I can't split it and have that hole still be in the middle and have that work out, I can shut off the hole and then add in the core later, right? So if you ever have any interior geometry that's going to require you to put a core in the middle of your mold, you have to use this shut off surface to kind of close that off, make the mold, and then make the core as a secondary operation. We're not going to do that, but I just wanted to talk about that a little bit. So if you go through this when you're making things, kind of remember if you have the mold tools, you're going to have your part, go to parting lines, parting surfaces, and then tool splitting. It won't let you do the tool splitting until after you have the parting surfaces set up. All right, so the next thing we can do is parting line, which is also here under mold tools. Should be here. I right-clicked on my bar, just someplace where there's not tools, and then go into tabs, and then turn on mold tools. Patrick also mentioned that he loves the direct editing toolbar. So if you want to investigate using these other toolbars, feel free. You know, if you find yourself using tools a lot that are kind of in this menu down here, and you don't like using the insert kind of yada, 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 I don't mind just pinning this and then just going into this toolbar and finding it out, but it depends on how often you're using it, right? Anyway, so parting lines. It's going to try and find the parting lines for us automatically, which we like. So I'm going to use my top plane as the direction of pull. It's going to do the draft analysis with that, right? And then it's going to say, hey, based off my draft analysis, I think you want to use these edges as your parting lines. And most of this is fine with me. The problem that I don't want is I don't want to use this as parting lines. You guys see that little corner right there? So the parting lines work most of the time, but you do have to check and make sure that it's working everywhere. If you have features that are like round or something, it will try and find the border between the red and the green and use that as your parting line, right? You can also use the split faces option, which will allow it to cut faces in half at certain draft angles. I don't recommend using the split faces because having it automatically decide where to make the split is almost always going to be less efficient than you just telling it where the splits actually should be, right? So like it's doing here, it found this flat face and says, oh, well, I'll just have this parting line go along the transition on the positive draft angle. That doesn't really make any sense, right? Why would I want to have a little bump in my mold like that? I really just want to use that line right here. So what I'm gonna do is I'm just gonna select these edges again to untoggle them and then select the middle edge to make that my new line. Everybody see that? I'm gonna exit the parting line tool and just do it one more time. So I'm going to parting lines. I'm picking my draft angle or my pole direction. I'm using the top plane. I did my draft analysis. It decided it wants to use these lines because it's all on the border of the green. I don't want to use those. I'm going to use these guys right here. So I just unselected those and selected the middle one. And now I've got my parting line. They're all kind of on that top plane, which is what I had intended for this part to begin with. Again, I'm just going to reiterate, I made this part with the idea that I would have a two-part mold and that the part itself would be in the middle of that mold, right? So that was my intention when I made this part. Any questions on the setup for the parting line? Once we got it the way we want it, we click on the green check mark. Now we've got our parting line set up. Next thing I need to do is I actually want to make my parting surfaces. The parting surfaces basically just extend the part out. So that way you can have the mold be designed around that part feature. I actually didn't do this one ahead of time. I'm a little worried now about some of the wings, but there should be fixes for that even if we don't need it. So I'm gonna click on the parting surfaces tool. I'm gonna check and make sure this is gonna work. Yeah, it looks okay. There's one surface here that's not generating properly. I'm gonna try making this a little bit bigger. And let's see if we can't figure out what's going on this edge here.
If you make the parting surface look thing smaller, it looks like it works. So like, did you change the 0.035?
Yeah, I want the line to be bigger. So one of the things that I'm doing, you have options for how you want the surface to come out from the part. And I can do tangent, normal, or perpendicular to pull. In this case, those should all be reasonably comparable, but it seems if I use my normal to surface, it does a better job of resolving that. And I want to try and make this a little bit bigger if I can. I think my part's just too big. My part is too small though. Let's try 0.05. That works. It probably is going to fail once these parting surfaces start intersecting itself. So can I do 0.1?
You want it to be bigger?
I want it to be bigger. Yeah, it's okay. We'll use 0.05. It seemed like that actually is still working. I've got a little bit of an error here where it's not quite overlapping, but I think we can probably work with that. Let's try if we turn off smoothing, will that fix anything? No, it doesn't look like it. All right, let's see if let's accept that. There you go. So what this is doing is adding this flange out to my part. And then I can use that to help design the mold. I don't like the fact that it has a little bit of that waviness to it, though. I'd rather it be flat. I'm going to go back to my parting surface and try and if I can edit to normal to direction of pull. Yeah. I like that a lot better, but it's not actually generating this on this face. So I think what I'll do is I'm gonna brute force this to make a surface to use as a parting surface manually, as opposed to doing it using the features, right? Yeah. So what I'm going to do is I'm going to suppress. Oh, I have an error in my parting line. What do I have an error in my parting line? Oh, well. So I'm going to, this is the automatic way. And we'll cover this one more time in a different example. But I can also just specify surfaces that I want to use. So I'm actually going to define a surface based off of a sketch. So I'm going to go to the top plane. I'm going to exit this real quick. I'm going to sketch in the top plane first. And I'm just going to make a box that's a little bit bigger than my whole part. Something like that's fine. And then I'm going to do features, or sorry, my mold tools, planar surface. I'm going to turn that sketch into a surface. Everybody kind of see that? I'll do it one more time. So the first way I was doing here was trying to automatically generate a surface to use as a parting surface, right? And then I'm just changing my mind and using just a planar surface, which is another way of doing it. And the planar surface, all I did was create a sketch on the top plane that's just a little bit bigger than my part. And if you want, you can add dimensions to this, right? Fully define it. Maybe I want to add dimensions just so I know how big it is. So it's 1 inch right now by 1.1 inches. I do need to make sure it's bigger than my part. It doesn't need to be a lot bigger, but it needs to be big enough that it's going to have that be interior to my feature. And if yours is a little bit smaller, a little bit bigger, don't worry about it. And then again, going into features, or sorry, going to my mold tool features, and it's turning it into a planar surface. That make sense? Now that I've got a surface here, I can use that to do my tool split. And when you need to do the planar surface again?
What did you extrude it to? Like,
so this is not extruded. This is just a surface. So this is not a body. It's just it's a 0 thickness part, right? So I created that sketch, and then inside mold tools, I just clicked on planar surface, right? So I'm not extruding it. I'm just making it into a flat plate, basically. Right? And so it's infinitely thin. If I were to get, it just shows up as a line relative to my, not my top plane, because I drew everything on the top plane. Just like the back. See? The mold parameter?
Yeah, for your parting surface. You're doing it on that.
So I tried doing it with the parting surfaces and it wasn't working. So I've suppressed my parting surface and my parting line, and I've manually made it a planar surface, right? So I'm not using the parting surface right now. We'll go back to that in a minute. So now I'm gonna use my tool splitting. So I have this surface dividing my part into two. It's not actually dividing it into two. It's got one body, right? But it's going to divide my part into two. Next thing I'm gonna do is we use this tool splitting, right? So I want to select a edge or feature where I'm gonna draw a cross section. This is gonna be inside the tool splitting. This is gonna be the boundary of the mold. So I'm gonna use the top plane again. And then what I'm gonna do is I'm just gonna convert the edges of my planar surface. I think if I just do the face, that'll work. Right? So I'm gonna do that one more time. So I just clicked on the face, clicked on convert edges. That's made the boundary of my planar surface a sketch inside the tool splitting feature. And I'm going to exit that sketch. It's going to say, hey, how far out do you want to go for this? My cavity, I want to use my my solid. Why is my solid body hidden? Did I accidentally hide that? Splitting. wonder if I need to merge my surface.
There you can open solid bodies and then right click on the split line to control line and then show.
Yeah, but,
It's not letting me add to the cavity though.
Oh, I see.
I think I need to turn. Yeah, I need to generate surfaces from that body. Let's see what happens if I use my edges here. Yeah. Let's go to the other example real quick. We'll come back to this one. And I'll show you guys a different way of doing this using the subtraction body options. So let's go to a new part. And we're going to use our typical cube. So I'm going to sketch a 1 by 1 by 1 cube. This is a totally new part, totally from scratch. And I was going to use this as a different example of some of the variations you can do when working with this, but we'll just use it as an example of how to use the tools as well. So I did a 1 by 1 by 1. So 1 by 1 on the sketch, center line. Doesn't really matter if it's center aligned or not. I like keeping things in the center. And then 1 inch thick. Again, I'm going to use a midplane. So I've got a cube. You guys, doesn't actually have to be a cube. If you guys want to make it a box or something, it's fine. Now, on this one, if I do draft analysis on this, relative to one of these faces, obviously I have large faces that don't have drafts, right? So if I want to make a cube, right, and I want the sides to actually be perpendicular to each other, right? How am I going to get a draft on this part? Do you have any ideas? Not really. So one of the things here is that I don't have to specify the direction of pull normal to one of the faces. I can have it go in any direction I want. So if I'm looking at the cube from this direction right here, all 3 of these faces are going to have a positive draft angle, right? And if I flip it over, same thing, right? So as long as I can specify the direction of pull, right, I don't have to be quite so planar as I was in the previous example, right, where everything was on a flat plane pulling apart. So if you're starting with a part that's not like very obviously, hey, I can draft this and pull it apart, you can choose the direction of pull such that you are able to manipulate that. Now, you need to have some feature inside SolidWorks that's going to define that direction, right? So in this case, I'm going to make a plane that connects the corners of this cube, right? So that way I can kind of have this direction defined a little bit more explicitly. So if you go into reference geometry plane, and then we're just going to pick the 3 corners on the perimeter of this cube. Now this guy, and this guy. And any 3 corners will work as long as they're on the perimeter and they're not adjacent to each other, right? So I can't use like these 2 corners and that corner. I need to have kind of opposite corners forming a triangle, right? An equilateral triangle. Anyone need me to do that one more time? Pretty straightforward. Again, I can go normal to this plane, and you can see that from both sides, everything is going to have an appropriate draft angle. When I run my draft analysis, if I use that plane, you can see that I have all red on one side, all green on the other side. Even with a fairly large draft angle, right? We're still all green and all red. I'm actually going to leave the draft analysis on right now. And then I'm going to go into my mold tools. I'm going to define parting lines. Again, it's going to do this automatically. The direction of pull, again, it's going to be my plane 1 that I defined. On the green check mark. In this case, because I don't have any oh, sorry, I didn't hit draft analysis. So inside the parting lines, click on the direction for the plane and then click draft analysis again. And then it's going to generate the parting lines for you, right? And then I can accept that. And then I can go to my parting surfaces. Again, it's going to extend that edge out. So I'm going to just make that a little bit bigger. The less complicated your parts are, the less complicated these parting surfaces will be. I want to do this perpendicular to pull. So I'm just going to click on perpendicular to pull. That makes these planes kind of a little bit flatter. But you can see they are following the edges of the part. And that's probably plenty big enough. So I'll accept that. Am I going too fast, you guys? Are you following along? Looks like you guys are following. Good. Sam, you good? All right. And then we're going to do our tool splitting. Again, I'm going to go back to my top plane, or sorry, not my top plane, my plane 1 that I just made. And I'm just going to offset the perimeter of my, kind of looks like a hexagon here. Although it's not, it's the projection of my cube. I'm gonna make sure I'm going that outward, so I'm gonna have it come out. And it just needs to be smaller than your parting surfaces, but bigger than your part. So pick whatever you want as far as size here that you think looks good. And then once you've got that defined, you can see how I was kind of cutting my part in half. I can accept that. So exit the sketch. And then it's going to say, okay, well, how thick do you want your tooling block to be? I just need to make sure it goes past the bottom of my part in both directions. So I'll just go out that way. That looks okay. Up in the other direction. Again, that looks okay. Just look at it from the side. Make sure you're going all the way across your part. And then click on your check mark. And now I've got a body here from the tool splitting that represents the other sides of my part. To see that, all I need to do is go into my parting tools here and hide the extra surfaces. So I'm actually going to hide all my surface bodies. Yeah. I'll go back to the start. Yeah. So here, this is where I have my parting surfaces. I'm going to do tool splitting. Again, I'm going to be sketching on my plane 1. And then I'm using the offset entities to offset kind of the perimeter of my part. I make sure I'm offsetting away from the part, not in. So I'm going to have to reverse this direction. Nope. Darn it. So I'm going to unclick the reverse just so it's going out. Exit the sketch. And then I just have to specify how far out I want it to go. I just make sure I'm going far enough out that I'm totally encapsulating my part. I guess you don't have to go far enough out to totally encapsulate your part, but most of the time you're going to want to, because if you don't, again, you're not going to be able to mold that portion of the part that's not inside the mold. If you wanted to make like a 3 or a 4 part mold, you could have it just go part of the way across and then make another part, right, and divide that up. And then again, I'm going to hide my surface bodies. I'm going to hide 2 of these just so we can see what one side looks like. Oh, I don't want the, I want to show that guy. Hide that guy. So this is just half of it. I'm going to turn my draft analysis off so you can see it without the draft analysis. So that's half of the mold. right? And if I show that one and hide that one, that's the other half. And really, you would take that and you can use that to, mill out your part or, whatever you wanted to do. 3D print it, and then you can put them together and make that mold into a three-dimensional piece. We'll cover, I think next time we're going to talk about how to take these pieces here and actually modify them so you can make a mold that will actually work. It hopefully is somewhat obvious to you guys that this will not work because I have no way of putting material into this mold, right? Like I've got no places to inject material. It's just a void inside of a part. Does that make sense to everybody? All right. The other way of doing this without using the automated tools, which is where we're gonna have to default to, with the automated tools don't work, you can still make the mold cavities inside SOLIDWORKS by dividing out parts. So what I'm gonna do is rather than trying to use the tool splitting tool here, is I'm gonna make a solid body that's the size of the kind of the tool splitting cavity that I used, but I'm gonna make it a separate body from what I have here, and then I'm gonna subtract those two parts to make two into separate bodies, okay? So I'm gonna go to my sketch that I used for, that I was trying to use for the tool splitting. I'm gonna extrude that. So I'm going to features, extruded boss base. I'm gonna use a mid-plane extrude. I'm gonna make it a little bit thicker, right? So it's thicker than my part. And then I'm gonna make sure I uncheck merge result. So when you're doing things like this, that's probably the only time where you wanna not merge the result. I wanna have two bodies, one for what I'm gonna make into my mold, right? And one for the cavity that's going to be subtracted from that mold. Does that make sense? So now what I'm gonna do is I'm gonna click on accept. I'm gonna subtract the boss extrude inner part, was calling the split line right here, right? That body from this body. So I'm gonna go into, I think we're in Surface.
It's in direct editing.
It's in direct editing, yeah. It's actually in the combine feature. So you're looking for combine, it's the same tool. If you go to direct editing, there's this combine. We're actually gonna use combine and split. So we're gonna start off with combine. And what I'm gonna do is I'm gonna subtract, right, from this body, the original body I have, which represents the geometry of my part, right? And the preview doesn't really do a whole lot, but you can see how it's cutting that out. You guys all see that? And now all I need to do is I need to split that body, right, across my existing one. So I'm going to pick my combine one. I'm going to split it about my top plane. And I'm just going to do all bodies and do cut. And it says, which ones do you want to keep? I can click on both of them. And now I have two bodies, each resulting of that split. I'll do that again if you guys want me to. I want to not have that face anymore. I'm going to just hide it. So there's one half of the mold, right? And if I show hide, there's the other half. And again, the first thing I did was my combine, where I just used the subtraction to subtract those two bodies apart from each other. And then the split, where I specified the plane that I wanted to use as the cut, which was the top plane, right? And then I just did all bodies. If you don't want to cut everything, you don't have to, right? You can always do that. Not a big deal. So that's kind of the more manual way of doing it. Either of those works fine to create a void inside of a part based off the initial size. One thing that you might also want to consider is if you're trying to account for the shrinkage of a part, right? Like a part's going to get smaller as it cools. Before I do any of the processing to make the molds, I can scale the part to make it bigger, right? So if I look at scale, so say I know this part is going to shrink by 1%, right? Hold on a second. before I make the mold part. So I'm gonna start with my actual part, right? I can scale this. Which I think is in the mold tools option as well. Yeah, it's right there. And again, I can scale the whole body, right? And I'll make it 1.01, that's 1% bigger. You can use the centroid, you can use the origin. I usually scare about the origin because I usually am somewhat conscious about where I put my origin. In this case, because I have a sketch picture that I use for this, my origin is not in a great spot. So I'll use the centroid, which will give you like kind of the center of mass. And so it won't move as much. But if you're, again, just pay attention to what you're doing there. It doesn't make a big difference. Now this part is 1% bigger. And I can go ahead and do the rest of my thing. I gotta make sure my boss extruder is still big enough. Looks like it's still fine, right? And go back and do it. And that's one of the advantages of doing this in SolidWorks is that your ability to go through and change things like the scale is super easy. So if I decide that this is gonna shrink by 3% and I wanna make it 3% bigger instead of 1% bigger, I can do that. You see my margins at the bottom here are getting a little too small. If I go too big, then obviously that's gonna be a problem. So if I do like, let's say 1.5, now I have issues. But if I had set my features here, right, to offset based off the size of the part, then it would automatically update and I wouldn't have those issues, right? If you're milling these things out, that's not always gonna work because you're gonna start with, kind of stock of a certain size. But if you're 3D printing it and then, using that for a low temperature molding or something like that, then it's not gonna matter, right? I'm gonna change the scale so that way something reasonable again. We'll use 2%. Anyone have any questions on any of that? Do you all have 2 molds, one for an eagle thingy and one for a cube? Cool. All right, so go to Canvas. You can go ahead and submit those files to, I didn't put a link to the assignment, did I? It's published though, isn't it?
Yeah, I think so.
Okay, so you should be able to find week 10 due today. And what I want you guys to submit is each of these molds, but only showing 1/2 of the mold. So it should look like this for this one, and then like that for the other one. You just show that you've made both those molds. Yeah, Patrick.
Now you know what's going on.
When you were doing, you trying to do the manual way or the automatic?
The split, subtract.
So yours, you're still showing up. I did it.
Which one?
Is there a same one?
Okay.
All right. That's it for today. Next time, we'll talk about how to add features to these molds to actually make them into moldable parts. For Patrick and Krishana, project 3 is to make a mold of a custom part and then to actually use that to create something. And you can use urethane, silicone, or some kind of food substance if you want to do like chocolate or something like that. That's fine. But the goal is to make the mold, 3D print the mold, and then use that to make something. So after next class, you should have all the tools you need to be able to do that, and it'll be due the week after that. So you got 2 weeks. But think about what you want to do for the internal geometry, the void geometry, and start working on that. If anyone else inside the class wants to do that, you just want to do it for fun or for senior design or something, feel free to work on that as well. We'll play around with it. Yeah, Sam. Yeah. Okay, let me stop recording though.